So now starting number one, the first one we have a simple model, right? And then we have mediation model, and for the sake of simplicity, we'll start from mediation model, right? Essentially, PLS-SEM has two stages, two type of, any model is divided into two parts. The first one is called measurement model, and the second one is called structural model. Yes? So before I go ahead here, let me show you the measurement model and structural model here. Okay. Essentially, you see there are two types of, one you see in blue, the other one you see in orange, I believe, orange or whatever color is this. Okay, the relationship between these observable, let me highlight, can I highlight laser point? Okay, the relationship between these observable and this latent variable, this is called outer model. So again, relationship between all these observable and latent variable here and here. This is, so first we'll measure the measurement model, another word the outer model. So first we'll establish that all these items are contributing to this latent variable, and then here in this latent variable and this latent variable, they're making significant contribution. And when we do this, we call it measurement model. Once we are satisfied with, that means once we are satisfied with reliability and outer loading and so much and so on, we'll be talking about that. Then we'll move on to the second part that we call structural model. And that you see here in this box, this is structural model. In a structural model, we are concerned about the relationship between one latent variable to the other latent variable. That means our predictor variable to our dependent variable, our predictor variable to our mediating variable, and then dependent variable. So there are two stages. Number one, the relationship between these, or contribution between these observable items to these latent variable, that's called measurement model. And then the next stage is structural model, where we are concerned about the relationship between these variables, right? So our hypothesis mean this is structural model, where we say brand A has a relationship, or satisfaction has a relationship with brand loyalty. That's structural model. The first one is like you check reliability and validity. This is what we're talking about, measurement model. Yeah, it's also called outer model because it's outside here, outer model, and it's also called inner model because it's between this relationship. When we check, we also call it inner model or structural model. Is it clear? Confusion? No? Same we are saying here. Okay. A small difference between regression and structural equational modeling. Number one, we know in structural equational modeling, everything is run at once, not one by one. Everything is run at once. Number two, in structural equational modeling, independent variable is called exogenous variable right here, and any mediator or dependent variable is called endogenous variable. Right? It's just the same concept. Independent variable, IV, is called exogenous variable, and mediator variable and dependent variable both are called endogenous variable. So we can do direct relationship, we can do indirect relationship, we can do interaction effect, which means moderation. We can do independent variable, that means exogenous variable, you already know, dependent, endogenous, and then mediating is also called endogenous. It's just a different name because there's a different perspective behind these variables. So they, according to that perspective, they have given a different names to these variables. Okay. First thing first, number one, we specified the structural model that we have already done in our smart PLS right now. We have specified relationship between variables. Next is measurement model, where we'll be checking CFA essentially. We'll be doing CFA. We'll be checking reliability. We'll be checking convergent validity. We'll be checking discriminant validity, so much and so on. And then obviously if you're doing a research, then data collection examination, right? We import data. and then you do PLS path estimation, then you check the results, and then you assess the results, and then finally structural model, then finally analysis and the interpretation of the data. This is what we'll be doing. Again, missing value should be less than 5%, there should be no highly skewed data, should be absence of outlier, and you should have the whole idea of running this way is that we are estimating these relationships are linear. Keep in mind we can also check non-linear relationship, but for that there's a different way of doing it, not the one I'm doing it. Draw the sample model as you see in my Smart PLS. You've already done it. Let's go back to Smart PLS. Okay. LTO is long-term orientation. That's a moderating variable. So I'm taking mediation as a first model there. I'll be checking. Let's do the measurement model. Look what I did. I went to play button, and then I go here PLS algorithm. I go to play button, and then I go here PLS algorithm. Yeah, everybody's with me. And then I click on it. And I just need to make sure the path is selected here, path. That's it. Right? The other thing I need to, I made a mistake here. Let me go back. Wait. Okay. Before I do that, let's go back to our data. Where is our data? Sample data right here. And if you click on sample data, here you can see a number of different findings that we need. For example, we said there should be no missing value, and if you look at here, it shows me that there are 22 missing values. 22 missing values. Common practice that people put -99 here just to identify that, right? And just to, in other words, nullify the impact of missing value. But that's not enough. That's not enough. We have a treatment for this. We'll do the treatment. We'll do the measurement model. The other thing we see is sample size. We see the indicators here, 30. It gives a lot of information. Importantly, it gives us a lot of descriptive analysis, total number, missing, mean value, mediation value, minimum, maximum. Okay. And look here. It says maximum 32. Don't you think it's wrong? Because from 1 to 7 scale, how could 32 be a maximum value? From 1 to 7 scale, any maximum value should be 7, right? So there's a data entry issue here. So this, when we upload, please have a look at very, very closely. It gives us a lot of very useful detail that we probably don't pay much attention to. Data entry issue here. Okay. So minimum value, like I said, and maximum value, then mediation. Okay. Let's go straight to standard deviation. The higher the standard deviation, if it's too higher, let's like 3, 4, then it's probably not good. From 1 to 7 scale, any standard deviation that is above 0.5 is good. Anything that's 0.5, that's not a good. That means somebody just check mark, just clicked it. They didn't really, there is no variation in their answer. So let's take a look at standard deviation by one by one.
Also implemented for the 5 scale.
Same. Anything 0.5 or equal to 0.5 is pretty questionable. What he was doing, the respondent, what he or she has been doing. Apparently they answered everything same to every question. So the problem with this, because it's a variance based, or even if it's covariance based, you cannot predict upon it. There is no variation, right? So the mean value of one respondent and the mean value of the respondent should be different. Based on that, I can say, well, yeah, this affects or not, this doesn't affect. If everybody is answering the same, there is no variation. All have the same mean value. There is no, actually flat. The correlation is flat. There is no correlation actually. Okay, so standard deviation. I'll scroll back, just have a look at it, and I see it's good enough, not bad. I can do the same in SPSS, by the way, or I can do the same in Excel. All of my data on the right side, once we did with Merriam, I can do on the right side, and I can run my standard deviation for each response. And I can see which response has extremely low standard deviation. Remove that. That's the one that doesn't help you. Significant or insignificant, that's a different story. Even in measurement model, it will not help you. Okay. Now the question of normality. Kurtosis and skewness. The most common I've seen is between -1 and between +1. This is most common, most accepted. And if you assess based on this, some of them are okay, and this has to be wrong because I've given the wrong data, I've input the wrong data. So ignoring this, let's take a look at here. Second one, between 0.18 minus to 0.1, that sounds okay. That sounds okay. It's between minus -1 and +1. It has to be in between. There are other one more stringent, minus plus 0.87, very stringent. The other one, minus plus 3. I take, 1 is fine. It has to be between plus minus 1. So this is fine, this is fine, this is fine. And here I see a little problem according to the criteria. According to the given threshold, it is exceeding little bit. It's going beyond the normality. Little bit beyond normality. Again here, same little bit issue I see. And then here I see the issue. Here I see issue. Here I see issue. Okay. I can definitely say that it's a skewed data and kurtosis are a problem, but I do not see highly skewed data here. Other way around, don't trust these numbers. Go to SPSS, draw a histogram and see how much skewed data is. Right? Apparently from these numbers, except for this first one, which is definitely has to be wrong because I've added some wrong value somewhere there. The rest looks, it's a skewed data, and I know PLS-SEM will take care of it, but it doesn't look highly skewed data. Are we okay? So we are done with the normality. We know a little bit about normality. We know we have some missing values here, and we'll take care of that when we go ahead. So let's go back. Let's go back to our mediation model here. Let me close all other models here. Yes, cancel, save. Okay. So let's go here. PLS algorithm. Can you run? Go to play button and run PLS algorithm. Just make sure the missing values here is mean replacement. You have clicked on it. It's properly. It will take care of missing values. But doesn't mean that if you have too many missing value, it has no effect. Obviously, it's going to have effect. It's better you have no missing value. But if you have it, just have this missing value, mean replacement. Other options are here. Those are not that. I wouldn't recommend that. Case deletion means wherever the missing value is, remove that whole line, remove that whole row. I wouldn't go to that extent. But if you want to, you can. Pure deletion is another option. I would stick to this. Waiting, I don't need to do anything. Just go to setup and then run. Are you with me all? Can I do it? Okay, run. Okay. Now, in order to assess our measurement model, how good or bad is that, we need to check outer loading. Essentially is CFA, confirmatory. Right? And then reliability, and then multicollinearity. That's about it. These three things for now we need to check. So let's go back to our model here. Number one, we need to check outer loading. Outer loading. And look, by each item is showing me outer loading. Ideally, it should be what? 0.708. It should be that. But in some cases, as long as even 0.534, I may take it depending how do I argue on that. But usually anything 0.60 should not be part of your model. Should not be part of your model. So you have two options. If you have low outer loading, one option, remove this one. Sometime it could put a huge question on the validity of your, even though reflective, sometime it could put a huge question on the validity of your construct. And sometime you believe that those items are highly correlated, almost the same thing matching, that doesn't matter, I'll just remove this one item. I'll go ahead and remove it and I'll get the right outer loading. 0.708 or 0.60 minimum you need in any case. Any case. Some people argue no, if it is exploratory 0.60 And if it is confirmatory, then it has to be above 0.70. I would say even 0.60 is fine. I can find many, and I have one source available for you. There you can find many citation for all these things, validation, whatever, many citation available. में फ़र्क आएगा. These will be. उनका criteria 0.3 है? Are you sure? I don't think that's in SPSS EFA जब आप run करते हैं. That's for EFA, madam. CFA 0.30? I would never ever do that. That's I would never ever do that. Actually, कभी भी मैं ऐसा नहीं करूँगा. मैं नहीं करूँगा ऐसा. अगर मैं बिल्कुल SPSS, if I am going towards SPSS, for example, still I'll take 0.50. I'll not take anything less than that according to SPSS. I need. I'm not sure based on what. It's a confirmatory. होना ही नहीं चाहिए इतना कम तो. Right. So. Okay, so I can't answer. I have no idea what is happening there. Madam, even let me just pause. So ideally, what we should be doing here we should remove this. Anything 0.60 should not be here. I'm telling you the most relaxed criteria is 0.60. Please keep in mind. Remove these two, but before you remove it, please make sure that it doesn't have any effect on the validity of your construct. For example, a concept is made with 4 different observable action, and one action you completely remove. By removing the item, you need to ask yourself, should I do that or not? Should I do that or not? Because sometimes it could put a huge question on validity, and that's the issue with formative. That's the issue with formative scale. Even the scale could be reflective. As a result, there are some researchers, some scientists who are saying there is no reflective, there is only formative. There are other researchers saying there is no formative, only reflective. They are all based on the same item, the same theory, that when you remove one item, you technically remove, it's like a body is complete by different parts, and if you remove one part, is it still a human? That's the argument, right? Because you have removed one part. So when one concept is completed by these 4 or 5 elements, you remove one element, the question is whether your concept is still valid, because there's one important element is missing now there. Is still capturing or measuring what you wanted to measure. Can we take these valid finding or not? That's the argument. So with cautiously, you can delete it. Ideally, in reflective, in most common practice, in reflective model, in reflective measurement, you can remove it, right? You can remove it. Nonetheless, you should read your item very, very carefully. You can remove it. Anything 0.60 should be removed. Okay. Once you remove it, so now it's showing me red because all these values are less than 0.60. The software understands only 0.70. Okay. We're okay with outer loading. I'm leaving as it is. I'm not removing anything. Let's go further. Outer loading is done. Let's go to reliability and validity. There are 3 types of reliability available here, right? Number 1 is Cronbach alpha, the most common one. The argument is that this is the most conservative one, right? And as a result, it calculates less than what is there. And here, composite reliability, they brought another one, composite reliability, it's called CR. They said this is a better way to measure the reliability of your responses. And then the argument came, they said now this overestimates CR. They say Cronbach alpha underestimates, very stringent, CR overestimate, and they said solution is here, rho, which is the rank Pearson correlation. They said this is a better one. Nonetheless, most common one, if you see, even in high impact journal, Cronbach alpha and CR are the most common. This is the reliability they report. इनके बीच में ही actually है. Any value that above 0.708 equal and above acceptable enough. As a result, you see all the results in green. कौन सा सही आ रहा है?
Composite. So,
Where is CR?
yeah.
Then I would say you can report CR. If they accept it, they accept it. If they accept it, they accept it. It's really up to the examiner, up to the reviewer. That's all I say.
So we can just report
And
CR
then-
and CD.
We can. Again, some reviewers, if you talk about publication, they're very specific. They want everything. Some they don't care about it. And then the average variance extract. Okay, remember we talked about keeping 0.50, 0.50 outer loading. You remember? If any of my average variance find, there has to be minimum 0.50 and above. If for any of my variable, average variance 0.50, even if my outer loading is less than 0.60, I can retain it. Idea is that is still giving enough variance, so you should retain it. But if it's not giving you 0.50 here, it's a huge issue. Then go check each of your item, which item has low outer loading, try to remove it to bring it here to a level where it is minimum 0.50 and above. This is a must. So real criteria is average variance extract. You can retain outer loading less than 0.70 as long as average variance is 0.5 and above. We are done with this. And next is, so we are done with three things. Number one, reliability, normality, reliability, average variance, and now we are going to discriminant validity. So where average variance identifies the variance, high variance between all the item or construct. Discriminant validity talks about whether there is enough distinction between all the concepts. In other words, there are two criteria. Main criteria is Forner Locker and HTMT. But there are other studies you'll find. Discriminant validity right here. I'm trying to go a little fast because we're left with time, not much time. Discriminant validity. So discriminant validity means we are establishing there is enough difference between these constructs. There's not too big or huge overlap. So actually, essentially, we're predicting the same thing with two similar variables. Yeah. So discriminant validity. Nothing we see. Actually, this is we call square root of variance of correlation between these variables. Very simple. Very simple. Benefits has the highest value with benefit itself. Yes or no? Yes or no? Benefits has the highest value 0.820. It's a square root of variance actually.
Shouldn't that be 1?
No, it shouldn't be. If it's 1, that means it has 1 correlation. That means 100%.
Benefit between
No, it shouldn't be 1.
Like he's asking about correlation as in
No, this is not exactly correlation, but it's a square root. It's a variance square root, rather. Variance of square root. Okay, it's not correlation. Okay, so commitment has a bigger value with this, right? Likewise, okay, the other way is cross loading. You remember outer loading? So same outer loading they have plotted here and they're trying to show here. If you look at here, BNF, for example, BNF. Look, BNF has highest outer loading with itself. With commitment, it has lower. Same thing here. Commitment, rather communication, or commitment, yes. It should have the biggest outer loading with itself. For others, it has small. Right? I would only check. I wouldn't go to this. I would take a look at everything, but I would report only HTMT. I would report only HTMT. This is most sophisticated and most advanced one. And in HTMT, ideally the value should be less than 0.90. And you can see one of my variable is overlapping with benefits, which means this is a huge question. What I am measuring with cooperation, what I'm measuring with benefits, apparently data shows same variation, same variance. As a result, it's trying to say that apparently these two are the same variable because we are getting the same response from both of these. If you're saying these are two different concepts, the response should be different. But apparently they are the same. The responses are same. Probably you need to remove one of them. That's the idea is.
If that value is much better, it's the point
Even 0.90 is fine. 90 is fine. But if it's above, then you need to go back and take a look at why there is a high. What is happening here? Why there is so much overlap? If you're saying these are two different concepts, but the HTMT said no, your respondent doesn't find it these two different concepts. Actually, they're finding the same concept. Look what is happening here. The variance is almost the same. The other values are okay if you see that. It's just the one is a problem. Okay. So, and then collinearity, multicollinearity, if you remember. Multicollinearity. Ideally, always take a look at this inner values. Ideally, it should be below below 3.3, and it's well below 3.3. I have this all on my slides. I've written here. I'm going to share these slides with you so you'll know it. What value you need. Okay.
इसमें भी जो higher है, इसमें भी तो recommend किया है कि अगर आपका 3.5 है, that's also acceptable, but better that it should be below than 3.
There's another argument which says the older book says the VIF should be minimum 0.0, minimum 2. That's another argument.
जैसे मैं जब आप इस तरह भी कहीं पे value आ रही थी, तो उसको वो indicate करें higher का reference है.
You can always. Okay, so we're almost done as far as measurement model goes. We are almost. Yes, Brian sir.
I'm saying कि whatever your minimum and maximum rules are, if my data is outside that, can I try to justify
You can.
that rather than rejecting that data?
Like I told you that it really depends how much you understand your problem, your data, and your population. They are looking for a very valid, plausible argument why you retained it. So what they do, they go back to the data, they analyze, they identify, they create a reasoning, they argue why I have retained it, despite it doesn't fit well.
For example, if I want to say the students who are coming into DBA, do they want to do marketing, HR, finance, supply chain?
Okay.
And ultimately, the result shows that they don't know anything what they want to do. And
Okay.
Which is a very scattered data. The skewness is out of range, and I, rather than trying to adjust the data into a normal skewness,
So-
I justify that they don't know.
So this brings this. That's how I assess it.
Yeah.
According to the problem, we have an analysis. So you're trying to put analysis to a problem which there is no fit. So what are you trying to exactly identify from that data? Based on that, I'll figure out which type of analysis I'll use. Right? So probably for you, cluster is a better analysis. You should be doing cluster, not this type of data. Right? That's what you want to do. You want to identify similar type of student in one group based on some type of variable. So you should be doing cluster, then this is not for you.
I started by trying to identify, but from the data I analyzed that they don't know, they are confused, they don't know what they want to do. This is what I want to analyze the result as.
Result what? What is the problem?
That is the result that I have tried to find out what they want to.
And how do you measure that? How do you measuring what they want to find out? What they want
By
to
asking them that yes.
asking what? Like as a qualitatively, quantitatively?
Giving them options, maybe for example, accounting, finance, HR.
Okay, then
But
are they forced to select only one or multiple?
let's say they all went to I don't know the middle one.
Okay,
Agree, disagree, and middle
fine.
one. So most of them.
So we are done with measurement model, and now we are going to PLS-SEM structure model. And for measurement model, I went here PLS algorithm, and for structure model, I'll go here bootstrapping. Bootstrapping. Can you all click on bootstrapping? Okay. And look here, a few things I need to tell you. If you pay attention, because we don't have much time, so we need to go a little faster. Number one, for analyzing your early data, Just for analyzing early data, 500 is okay, 200 is okay, 1000 is okay, but when you're doing the final data, final results, it should be 5000. It will take a while. It's called resampling, bootstrapping. And you should be selecting.
Yeah, I didn't get this.
Okay, if you just look at my screen here, originally I had this 500. I'm doing it because I want quick result, because the software takes time to process my data. But when you do your final results, when you do you need the actual results of your data, you should be doing 5000. Take a look at, I'm putting 5000 there. This resampling should be minimum 5000, right? There's an approach called bootstrapping. That means what it will do, in order to assess the relationship between one variable, the other variable, it will create 5000 different subsample of your sample. And based on that, it will say that, okay, whether there's a relationship or not. Originally, it should be 5000. But because I want quick, I'm doing, just to show you, I'm doing with 500, so we can quickly forward. It should always be complete. Likewise, bias corrected, and likewise here, one-tailed. In most cases, we should be using one-tailed, not two-tailed. In most cases, we should be, you just need to those situations. If you don't know the relationship, the type of relationship between variable 1 and variable 2, whether it's positive and negative, then go for two-tailed. But if you know definitely you're trying to prove it's a positive relationship, then you should go for one-tailed. It's called directional or non-directional hypothesis. If your hypothesis is a directional, you will use one-tail. Is that okay?
If it's not clear, then go to
Two-tail. Why would it be not clear? Are you doing completely theory building? Then yes. In most cases, we know. Then go for two-tail.
because there were a lot of complementary, results, findings from in the literature. So I went with the basic.
Okay. So one tail is most recommended in most cases. So again, we are done here, and then do parallel processing. It should be here, bias corrected, two tail, and look here. We don't do anything. Just you don't need to do anything. Some people say put 700 here. I don't do that. Again, selected path, missing value. Again, mean replacement. I don't need to do this. It's automatically, and then run setup. As soon as you do it, you should be able to see the results. Look, even though I put 500, it still is taking time. And when I'll do moderation, you will see it'll take a lot of time. So right now, in this we have all the results. In this we have all the results. We have results from relationship between this and this here, and from this to here. For all these paths that we have drawn here, we have the relationship. We can also take a look at report from here. If you look here on the left side, report. I can change many things here, and then you know this is the area you should be playing, so you know what I'm talking about. Report, go straight to path coefficient. Path coefficient, and then drag it here and take a look at. So the relationship between benefit and commitment significant according to the p-value, which should be less than 0.05. The relationship between commitment and cooperation is less than 0.00. Again, communication, commitment, however, one variable, one relationship, shared value to commitment appeared to be insignificant here. Why? Because it's much bigger than 0. It is actually 0.05, say, it's bigger than 0.05. So this relationship we failed to prove according to our data. Okay? Now, but this is direct relation. If you remember, this is direct relationship we're talking. What about this mediated relationship? Does this variable mediate the relationship between these three and this? If this is what we want to know, we'll go back to our results and we'll go to a specific indicator. And look here. All these three paths, from shared value to commitment to cooperation, this is insignificant. So commitment does not mediate the relationship between shared value and cooperation, but it does mediate the relationship between benefits and cooperation, and between communication and cooperation. So for these two paths, and let me show you from this way. Let me show you here. Look, you see this? Benefit, right? This path here, benefit. Okay, benefit. This has the highest impact, and then this has the less impact, and this actually is insignificant. This is insignificant. Yeah? Okay. So in this results we see that the mediator.
But we haven't got this one.
Okay, don't worry about it. Let me remove it. I don't want to confuse you. Off. Is that okay? Is that fine? Right? I go here and this tells me which relationship is significant and which one is.
Value or use absolute value?
Absolute value, I can take, actually, I took the relative values. Absolute means the negative, it will look at the negative as well. Okay. So, according to our hypothesis, if our hypothesis is this, that mediator, if we have three hypotheses, the mediator mediates between relationship between communication and cooperation, between shared value and cooperation, between benefits and cooperation, and the one we see here in red, this one we failed to prove. The other two relationship are proven to be correct, as there is a mediating impact of commitment.
And this is full mediation?
What was that?
Is this a full mediation?
It is a full mediation. I don't have direct path. It is a full mediation. I don't have a direct path here. If I put a direct path, they'll be different. If I put a direct path here, look, the results will change now. I think results will change. It'll take even longer. Okay. You see that? Okay, now look at the difference. So between communication to cooperation, this is the direct path we have taken. All these three direct paths, they all are insignificant. However, there's one path that has become significant, which wasn't significant. And if you look at the specific indirect effect here, it remains the same. There is no difference. The values have changed, but nonetheless, the significance has not changed. Okay. Are we done with this? Right? And let's go to now. So this was mediation. So there is a mediation. I could have, if I have direct path, I'll draw direct. If I have mediation path, so other way around could be that some paths are mediated, some paths are not mediated. It's up to you according to your hypothesis. Let's go to moderation. There's a little bit difference between moderation and mediation, as theory is different. Look, and I cannot take any variable as a moderator unless the data and rather theory proves that this variable has been established as a predicting variable, as a predictor to this dependent variable. I cannot take any variable as a moderator unless there is a substantial evidence this is actually a predictor to my dependent variable. Because this assumption is there, and keep in mind, because of this, because moderation, in order to run moderation, this path has to be there. Even though this is a moderator, but I am testing it as a predictor as well. If you look here, this is the first, right? And now this is just a predictor, and I'll make it moderator. Add moderating effect. Should I do it? Ms. Mariam, should I do it? Add moderating effect. And look here, the moderation where? Moderation between this and this. And which one is moderating variable? This. I draw one path here, and then right click on the second, where it's connecting, and then I said add moderating effect. Add moderating effect. Right? It already knows my dependent variable is compensation. It already knows it. And the moderator variable, I know long-term orientation is moderating variable. And the independent variable, which one is commitment? Because if you look at it, is in between commitment and cooperation that I am arguing that there is a moderating effect of it. Then I select product indicator. This is most recommended one. Miss Mariam, are you with us?
No, I don't.
Achha, go back, cancel.
Add moderating effect I've done.
Okay, let's add moderating. So we understand the moderation between this path and this path. We are saying this is moderating. So add moderating effect. It already knows cooperation is my dependent variable. Moderator is long-term orientation, and then commitment is my independent variable. If you look at this, how we have done it. This is commitment. We're saying the path between these two, this relationship is moderated by this variable, right? What is happening here? Okay, I guess I have. Okay. Okay, so I go here. When I go here, it already knows my moderation is cooperation. My moderating variable, I have to tell him, right? Long-term orientation, and my independent variable is commitment. Ms. Mariam, are you with us? Just click product indicator. This is most recommended one. That doesn't mean the others are wrong. It's just the most recommended one. The rest as it is, automatic, it knows anything, and then run OK. Now you see I have a new, it's called interaction effect. I have a new variable here. And this variable essentially means this. Look what I'm doing here. Commitment into LTO. This is what it is calculating. It is multiplying LTO with commitment, and then it's checking moderating effect. So it is, LTO is here as independent variable anyway, and here it is LTO is checking the moderation effect, whether it's there or not. Should I run it now? Should I run it?
Yes.
Now, because this is my, and I renamed it, so I know there is no confusion. This is my moderating variable actually. This is moderating variable, but this is the moderation effect I'm testing here. Then I go here and I run bootstrapping. Again, should be 5,000. You know all those requirements. And just to do it a little quick, actually it still is going to take a while. Let's wait. So how much is left? We're only left with 2-3 things, and I think we should be able to done by 1:15. Take care. If you want to go, you can go. Let me complete it. I can't. ठीक है. This was मेरे तो खुद ही भूल गया. Okay. When I was inviting a friend of mine, this was I knew it would happen. But what to do? He's also important for me. Okay. So again, the results are here. And if you remember, I've already tested the other relationship. My interest was here. I wanted to check whether LTO has a moderating effect between commitment and cooperation. And I see here value in green. That means there is a moderating effect. There is a moderating effect. Right? Is that okay? Any question about this?
I have a question.
Yes.
When we add the moderating variable, we haven't still added the moderating effect.
We have.
No, I'm just assuming. No, even if we do add the moderating effect, sometimes it happens that the moderating effect is invalid, it's insignificant, but the moderating, the variable is significant.
Means this path is significant here, this path is significant?
Yeah.
That's the most common one. That's the most common one. No, we don't do anything. There is no moderation effect.
So we say there's no moderation.
There is no moderation effect. We don't do anything.
The
Like,
variable
yeah.
part is significant.
Where is the complex one is there when there's a direct path is insignificant, but the moderating effect is significant. That's the real question now. Where is it happening? When we check as a direct result, but when it meets with the other variable, it starts doing the moderation. That's a complex one. This is simple. There is no moderation.
So
There
we
isn't.
say that then it will act as a control variable? Can we say that?
Like, why do you want to control? Control variable is different.
But
That's
also
the-
you need to state the control variable.
I will do that. Very simple. Acha. Let's do this. Acha. So we are done with two things. We're done with measurement model, we're done with structural model. We understand the structural model is done by bootstrapping, we know mediation, we know moderation now. So let's do this. Okay, what is next? What is next? Okay, now three things we need to know. Okay, look, when we did, and I'm going here from here, the three things we need to report: R square value, like in regression. Remember, we can take from, okay, we go here. Okay, we remember that when we run here, we remember that when we do measurement model, keep in mind when we do measurement model, we don't create interaction term of moderation. We don't create that, right? So in order to do R square, I went back to PLS algorithm, right? Simple model without this, close it. Yes, okay. Simple model without interaction. I went here, run PLS algorithm, and report R square is right here. R square, not adjusted R square. This argument adjusted R square is misleading. So they don't talk about adjusted R square anymore. Talk about R square. You know, the higher it is, the better it is. Yeah? You see, it's very high. I'll be very, very high because the fudge data. It's not the real data. It's a sample data. It's very high. Usually in marketing, in psychology, any conceptual, this is too high. This tells me there's something wrong going on. There's something wrong going on here. I saw in one case that was like 99%, 90% something. One of students, and he admitted about it. Yeah, I did that. It's not possible. It's not possible.
What is the ideal value?
Right here. Look, R value of 0.75, 0.50, 0.5 are considered substantial, moderate, and weak. 0.75 is too big. I'll be honest with you. In marketing, HR, psychology, too big. This is good for economics. Should be. This should be there. But not for primary data. For concept, it's a concept. No, it cannot be. Okay. So R square
0.25 is not called weak in social sciences.
depend. Who are you referring to? New knowledge is this. This is here. The new knowledge is that. Actually, the older one was that even 0.10 was acceptable. Now they're calling it weak. Actually, earlier 0.10 was fine. Now they call it. It's weak. Okay. Right. It really depends. Okay, let's go to. So we are done with. Okay, look. So I found out R square from where? From measurement model results. But if I want to find out effect size, I'll go here, bootstrapping results here, any bootstrapping results, and look here, F square value. This is one, F square. Now, look here with the F square. Don't look this. Don't worry about this. Worry about these values here. Yeah, and go here and take a look at. They say values that is minimum 0.02. That gives like a minimum. There is some minimum contribution. Alone, that variable is contributing to that dependent variable or endogenous variable. Minimum 0.02. If it's less than this, simply you need to drop that. You need to drop that variable. There is no other option. Weak, moderate, strong effect size. Where did I do that? From bootstrapping. That means structure model. Then from here I had a look at this. Is that okay? Okay. Next, Q square, blindfolding. Keep in mind that earlier they thought that the variance was enough to predict it. Now there are many other ways of predicting the dependent variable. One of them is blindfolding, the other one is PLS predict that we'll not be talking about in this. Okay, let's go here. Blindfolding. So close all this, simple same model I've taken here, select, and I go for blindfolding. Essentially what it does, blindfolding means I close, the idea is that you don't know what is happening. Let's see if you can blindfold based on the in sample result. Okay, so this is what they do. Simple, omission distance 7 is fine, same. Some people say increase it, I don't do that. Okay, mean replacement, and then run it. Okay. Any value. Keep in mind, here we are concerned about the prediction of what? Prediction of this and this. We want to know how much this is being predicted and how much this is being predicted. Am I correct? These are predictors. How much these predictors are predicting this, how much these predictors are predicting this, and how much this is predicting this. This we want to know. Essentially, we just want to know the value of this and this. That's about it. Any value, and let me make it bigger. Any value bigger than zero gives you that there is some prediction going on. Right? So 0.24 is bigger than 0, prediction. 0.587, bigger than 0, prediction. Values higher than 0, 0.2 are depict small, right? Any value that bigger than 0 is small, 0.25 is medium, and large is 0.50. Is a higher prediction. You say, well, there is a higher prediction. They can predict it, right? So the other thing, last thing I wanted to do post hoc. Okay, post hoc. Can I do that? Go here. Blindfolding, mediation, bootstrapping. Look, there is another argument. They say that you cannot take just because. How do you know the statistical power of your model? This cannot explain it. So what they do, they go back to, and I'll take you back to Daniel Super. They say that you need to check your results from. Okay. Let me go back. Home. Related calculators. Okay. So the few things we can do, we can argue whether our results are. Okay, how do I go back to calculator? Why I'm not able to see, return to danielsuper.com. Okay, statistic calculator. And from here we did, if you remember, here we did the sample size, and right underneath you'll see statistical power, right? And here you'll see multiple regression, post hoc, statistical power. Essentially, when we talk about our bootstrapping result, which means a structural model, they say don't take the result as it is. Check from ad hoc test called ad hoc test, right? Post ad hoc test. They say check from here. For example, so check how many predictors were there. Let's say our predictors were 5, for example. Okay. Observe R square was R25. Right? For each endogenous variable, we have to check for each endogenous variable. Let's say observe R square is 0.05. Probability level is 0.5. Sample size. What was sample size? 400 probably. Yeah. Okay. And then we calculate. This tells us anything above 0.80, it has a very high statistical power. It's a very high statistical. That means our results are good enough. We can take it. Other way around, if your results are insignificant, go check the statistical power using these values. If the statistical power not there, if anything is less than 0.80, which is right now is 1, which is ideal, then you can say that, well, perfect, these results are insignificant, but the overall statistical power of this model is not good enough. So even insignificant doesn't count here, actually. If statistical power is not there, there is something wrong with the measurement, the way we have measured. There's something wrong with that. So in that way, just the results are not enough. The new idea of statistical power has to be there. Yeah. We're just left with few things. Remember, I talked about checking CMB. Checking CMB through. Let me do this. Checking CMB. I'll go to simple model. I just want to know CMB because I said I'll remain in SPSS. In Smart PLS, and I'll not go into it, even though I can check CMB from very easily. Very simple. The idea is that take any. Look here. I have another variable called weather. Let's put that here. Weather. Idea is this. Okay, let's put it here as a weather. Take any variable that you believe has no relationship whatsoever with your modeling. No relationship. For example, if you think the age of the respondent has no relationship with my overall study here, you can take the age here, even though age may have a relationship. Here I've taken the weather, right? And remove all these relationships. This I'm checking what? Oh, sorry. Let's do this first. PLS algorithm. Two things we need to do. It's called full collinearity assessment. Go to VIF, measurement model, VIF. No value is as high as 3.3. Okay, but that's not enough. We need to go back here. Weather. Take weather here. Why I'm taking weather here? Because I believe weather has no relationship whatsoever with my results. Even if I do that, it will have no impact. Select here. Here and connect all these with this. Just make weather dependent variable. Full collinearity assessment through full collinearity assessment and run PLS algorithm again. Keep in mind weather has nothing to do with my model. Now go VIF. Do you see VIF values as high as 3.3? No. We can establish that through full collinearity assessment. We can establish that there is no CMV issue, which is common method bias issue, which is common in questionnaire. Right? We're done. 3.3, less than 3.3. First we check the VIF. If there's already VIF available, then there is collinearity issue. There is high collinearity, high CMV issue. But the other way we check by adding, we call unrelated variable here.
Is it also compulsory we have to do? Or
CMV is compulsory. How you do it, that's up to you.
just we have to go through the VI, that's sufficient, or we have to?
No, that's not sufficient.
Okay.
That's not sufficient. Then we have to do this way. Right? Some really depends, who are you submitting to, common method variance, also common method bias. Well, there is some bias when the respondent are responding to your questionnaire, there's some bias gets involved either because of the procedure or because of their personal bias. We check that whether the bias is there or not.
Okay, also multi-collinearity?
Multi-collinearity, yes. This is full this is called full collinearity assessment. Through multi-collinearity we checked it. So first we check multi-collinearity, then we added that variable, then again we check multi-collinearity. How to report it? I'll share these slides with you so you won't need them. Look here what they're doing. Reliability and AV is always together. Mostly this is most common way. I've taken from one paper. It's most common, simplest way. Discriminate validity. It seems like I'm foreigner locker. This is foreigner locker, I think. It's foreigner locker. I prefer HTMT. I only report HTMT. I don't report anything. But this is probably old one or HTMT. I don't know why I've taken foreigner locker here. And then a lot of people prefer to, put a picture as well of their model, bootstrapping model. Some people go even measurement model, they show differently because graphical model comes. So if you put that way, fine, there's nothing wrong. And then structural model, each path results here. There's here p-value, t-value, path coefficient. Okay. Okay, so what we did in this session, actually, we did some of the very basics. We started what is PLS-SEM, what is the construct, what is PLS-SEM, why should we be doing, PLS-SEM, why should we be preferring PLS-SEM over CB-SEM. However, these are very basics. There are other concepts, or also those are not really advanced, but beyond basics, such as how to treat reflective versus formative construct, how to treat multi-group analysis, how to treat categorical variable, how to treat consistent PLS-SEM, repeat indicator approach, PLS predict, 4 type of modeling: reflective, formative, and formative reflective. There's a lot we can discuss if we have time, and we can have another session, we can go through that as well. I have given you some resources. If you take a look at there, on the top one, this is a very famous American researcher James Gaskin. This is his actually website. This website, what it does, it has all the citations for all these things divided by reliability, validity, and such. Just go to that, open that paper, and they'll have citation for something. You want to know the VIF, what is the VIF, what is citation for VIF writing paper, go to this link. It has all those papers available whom you can cite. Book, the book for this PLS-SEM, by here, there are two books. One probably came in 2014, the other came in 2017. I'm not sure which one I've uploaded. I uploaded here the book. You can download. Right? I'll remove this link after a while because I have to upload this video in YouTube, and my whole video may be removed because of this. So I'll remove this link after a week. So you should download the book as soon as possible. And then if you want to know how to use and how to report, take a look at this here 2019 paper. They're giving you complete detail how to report each of this, how to report measurement, how to report other things. Yeah. Any question?
So you should be giving us the recording which is unedited, so we know.
You wanna have unedited? I'll give you unedited, because for me to upload YouTube, and there should be edited one. I'll give you. ठीक है. I'll give you the slides. ठीक है जी.